Hello students, welcome back to my channel. This is Serge and today we will discuss exercise 2.3 intro, which has functions in it. And apart from that, we read what are the types of functions. Okay, so let's begin. Our very first topic is function. Function. The definition of function given according to NCERT is a relation f from a set A to set B from a set A to a set B is said to be function is said to be function if every element of set A has element of set A has one and only one image in B. One and only one image. Okay. So what does this definition mean? Let's read it out. A relation f from a set A to a set B is said to be function if every element of set A has one and only one image. Let me take an example. Consider this B set. A, B, C and D are the elements of the P set, and the Q set has the elements E, F, G and H. Okay, these are the two sets P and Q. Now, how are the elements of P related to Q? These are related as P related A related to E, B to F, C to F, D to H. No, not C to H. C to G. Okay. Now see what the definition says. A relation f from a set A to a set B is said to be function if every element of set A has one and only one image. It means that a function is a special type of relation in which the each element of a P set has a unique image in the Q set. Okay. And students, note that it is given every element. Here it is given every element. I am double underlining it because it means that the P set must have it is must that every element of the P set has an image. There should not be an element which doesn't have an image. Let's consider D doesn't have an image, then this type of relation is not called function. Okay, let me redraw it. And what if the C set or the C element of the P set has also an image like this? This is also a function because B and C have only one image, no matter what image does they have. Okay, so this was the function, and now let's take some example regarding the functions. But before that, pause the video to note it down. Okay students, let's take 8th and 10th example of this intro. But before that, let me tell you a thing. How is function defined, or how is function represented? Function is represented by using this f colon A to B. It means that function is defined from A set to B set. Okay, this is how the function is defined. Let me raise it. Now let's take the 10th example. It states that let n be the set of natural numbers and the relation R be defined on natural number such that r equals to xy is equal such that y is equal to 2x and xy belongs to natural number. Afterwards, we need to find out domain, codomain, and range of r. And apart from that, we also need to tell that is this relation a function or not. Let me write down the question. Let n be the set of natural number, n be the set of natural number, set of natural number, and r be the relation defined, and r relation, I'm writing relation as rel, and we defined on natural number, on natural number such that r equals to xy such that y equals to 2x. This is how the function is defined, and x and y belongs to the natural number. We need to find out domain, codomain, and range of r, and apart from that we need to find out is this relation a function or not. Okay, write down the solution. Okay students, what are the natural number? Natural number are the numbers starting from 1 and ending till the positive infinity. And what if we start finding the y equals to 2x, where will it go? I think it will be endless, and we can't count it down from where it is ending till where it is ending. Okay, so what the question is asking, he is asking what are the domain, codomain, and range of r. Codomain, range of r, and apart from that he's asking is this relation function, is this relation function a function. Okay, so what will be the domain of this relation? Domain will be a natural number, set of natural number, and codomain will also be natural number, and what about range? Range will also be a natural number. Okay, how can you say that range is a natural number? Here it is given that y equals to 2x, and when you put uh, x something, you will have, I think, when you put x, let's say 1, you will definitely have 2. And what if you put 2 0.5 in the place of x? No, you can't put 0.5 because 0.5 is not a natural number. You can put 2, 3, and so on, and 2 will give us 4. When you put 1 we have 2, and when you put 2 we have 4, and from here you can conclude that we'll have range as even natural number. Okay, now it is asked that is this relation a function? Let's see. Yes, this relation is a function because each and every element has a unique image. Okay, no element is repeating the same image again and again. Okay, this was the 10th example, and let's move to the 11th example, but before that pause the video to note it down. So students, so 11th example is examine each of the following relations given below and state in each case given reasons whether it is a function or not. State whether function or not. Function or not. Okay, our very first part of this question is r equals to 2 1 3 1 4 2. This is the first part, and we need to find out is this relation a function or not. This is relation, and if you see here that 2 has the image 1 and 3 has also the image 1 and 4 image is 2. Okay, students, if you see here, I already told you that no matter if a single element has, if the two elements has one image, there is no problem in that, but it cannot be possible that 2 has the image 4 here, 2 has the image 2 here. Okay, this is not a function. Now it is function at the moment 3 1, I think it was 3 1, yes 3 1, yes, this is a function because every element has a unique image. And the second part is r equals to 2 2 2 4 3 3 4 4 3 3 4 4. Now see here, is this relation a function or not? This relation is not a function as 2 has two images, two distinct images. One image is 2 and other image is 4. 2 is having the two images. Okay, so this is not a function because 2 is having two different images. Let's see what does our third part says. R equals to 1 2 2 3 3 4 4 5 5 6 6 7 3 4 4 5 5 6 and 6 7. Now we need to tell, is this relation a function or not? This relation is also a function because every element has one image. Okay, one is having one image which is 2, 2 having 3, 3 having 4, 4 having 5, 5 having 6 and 6 having 7. Yes, this is also a function. Yes, this is also a function. Okay students, now let's take 12th example, but before that pause the video, note it down. Okay students, let's take 12th example, but before that let me tell you what are real valued function. Real valued function. Okay, a function, definition of real valued function is a function which has either r, which has r or one of its subsets, or one of its subsets as its range, are called real valued function. Are called real valued functions. Further, if its domain is also either R or a subset of R, it is also called real function. Further, if its domain is also R, its domain is also R or its subset, it is real function. Now we have two distinct definitions which are interlinked with each other, and the first one is real valued function and other one is real function. Okay, these are the two definitions which we have covered. Okay, so let's see what does the real valued function says. A function which has either r or one of its subsets as its range is are called real valued function. Now let's see what does this mean. It means that if the function has either real number or one of its subset as its range are called real valued function. Now what are the subsets of the real number? This r means real number. Okay, I'm writing here real number, either r or one of its subsets. Its real number subsets are natural number, integers, rational numbers, etc. Okay, and further if its domain is also r, its subset it is real function. And if the domain of the set is also a rational number or a real number or its subset, then the function is called real function. Okay, now let's take 12th example, but before that pause the video to write it down. Okay, we have here I have already written 12th question. It states that define a function fx equals to x plus 1. We need to define the function using this function relation fx is equal to x plus 1. Okay, this is the function which you need to define, and after that we need to fill this table. Okay, and the table is given here, and the coordinates of x are given as 1 2 3 4 5 6 7, and y we need to find out. Okay, so let's take f1. What we need to do is just replace fx, the value of x1 use. Okay, when you replace value of x with 1 you have 3, and when you replace f with the 2 you have 2 into 2 plus 1, which you have is 5, and so on. You need to do it. Okay, I'm leaving it on you guys, find it out, and if you have problem write in comment section, I'll reach you there. Okay, pause the video to note it down. Okay students, now we will take some functions and their graphs. Okay, and their graphs. Okay, our first type of function is identity function. So what is identity function? And identity function is defined on the set of real numbers such that by y is equal to fx is equal to x. So what does this mean? And the x belongs to the real numbers. It means that the identity function is defined on the real numbers by fx, y equals to fx equals to x. Let's understand this term. This is very important. Let's say I have taken x1. When you take x is equal to 1, we'll have y is equal to 1. Okay, this is the meaning of this identity function. It gives us the same value again and again, and its graph will be drawn as like this. Let's say 1 2 3 4 1 2 3 -1 -2 -3. I'm roughly drawing here -1 -2 and -3. This is y x dash y dash. Okay, the real identity function gives us the line like this, or it can also be like this or something else. Okay, let's understand. When we put the value of x is equal to 1, we have 1, such that x is y is equal to 1, x is equal to 1. Let's try to draw this. value of y is equal to 1, x is equal to 1. Its graph will be, its point will be here, and when you put x is equal to 2, y value will also be 2, and so on, the value will go on. Okay, this will be the function, this will be the graph of the identity function. Now let's talk about the constant function, but before that, pause the video to note it down. Okay students, let's talk about the constant function, and it is second constant function. As the name suggests that the function is constant, and this function, the function is always constant. Okay, and the function is defined on real numbers such that y is equal to fx, function defined on real numbers to real numbers, and such that y equals to fx equals to c, where c is a constant and the value of c is never goes up and down. Okay, and x belongs to r here. Okay, let's do the graph of the constant function. Okay, 1 2 3 4, -1 -2 -3, 1 2 3, -1 -2. Okay, so what does this mean? Y is equal to fx is equal to c. Whatsoever will the value of x, the function will be constant. For example, the graph of function is drawn like this, or it may also go in the negative y. Okay, this is the function, this is the graph of the constant function. Okay, and the domain of this function is real number, and range is constant because the value of c is constant and the range is also constant. Okay, for example, you take fx is equal to 3, fx is equals to 3, it means that the value of c is 3, and the graph will be done as like this. Okay, now let's talk about the polynomial function, but before that, pause the video to note it down. Okay students, let's take a peep on polynomial function. What is polynomial function? What is the meaning of polynomial? I think you may be familiar with this term polynomial. And polynomials are said to be the terms having the power like this: a to the power a0 plus a1x plus a2x square, and the power of this x goes on rising and rising. Okay, and last up till a to the power n and x to the power n. Okay, this is the type of polynomial. This is a polynomial, and the function is defined on this polynomial, and the function, and the n here is a integer, n here, n equals to non-negative integer, negative. And you know why I use this non-negative integer here? The non-negative integer means here that we have also included 0, as in this term we are not having any x to the as we are having x to the power 0 here. Okay, and what is x to the power 0? X to the power 0 is 1, and that's why I have not represented here. Okay, the function, the type, and some example of this function are fx equals to x to the power 4 plus x cube plus 3, and something like this. Okay, these are the types of function. And let's talk about, there is no graph of, and students, one thing more, there is no graph of this function, and it can be done in any way. Okay, now let's talk about the rational functions, but before that, pause the video, note it down. Okay, students, let's talk about the rational functions. What are the rational functions? To understand rational functions, you must be familiar with this rational numbers term. Okay, this rational term, where the rational numbers are the numbers in the form of p by q, where q is not equals to 0. And if you define the rational functions, the function in the form of are of the type of fx by the gx, where fx and gx are the polynomial functions of, okay, where and representing where by this inverse a, and okay, where fx and gx are polynomial function, polynomial function, okay, and gx is never equal to 0. Okay, and as in this term, q was also not equal to 0. Okay, if this, what if this x gx equals to 0? This will be non-defined, because we cannot define a function from which the dividend is 0. Okay, we cannot define the function which has dividend 0. Okay, that's, and in this rational function there is also not a graph, specialized graph. Okay, let's talk about the modulus functions, but before that, pause the video to note it down. Okay, students, let's talk about the modulus function. It is the fifth type of the function, modulus function. Okay, modulus function. What does the modulus mean? Modulus, let's see, we have the x, and the modulus is represented by using this double slash, double lines. Okay, and the modulus function is defined on real to real numbers, on real to real numbers. Oh, sorry, I forgot to mention here. Function is defined on real numbers such that fx equals to modulus x. Okay, and for each x belongs to R is called modulus function. The function when x belongs to the real numbers is called, when x belongs to real number is called modulus function, and there is no other definition of this modulus function, and you may be familiar with this term. Fx equals to x when x is greater than equal to 0, and minus x when x is less than 0. This is the definition of this modulus function. Okay, and you will come to know in this definition in the 13th chapter, which is limits and derivatives. That's why this chapter is said to be the very important chapter for the base of this 13th chapter. Okay, if you don't know this chapter, what are the functions, you will not be able to get the 13th chapter. Okay, and the graph of this function is drawn like this. The value starts from the minus and goes to the positive. Okay, I'm not writing here values because it becomes it takes a little bit time. Okay, now let's move to the signum function, but before that, pause the video to note it down. Okay, students, let's talk about the signum function. What is signum function? And this is the sixth part. Signum function. The function is also defined on real numbers, and fx in this case equals to 1 if x is greater than 0, 0 if x equal to 0 equals to 0, and minus 1 if x is less than 0. This needs to be fulfilled if the function is singular function. It means that a function which is singular function must have this condition in it. Okay, one should be the value if the x value is greater than 0, and 0 should be value if the x value is 0, and minus 1 if the value of x is less than 0. And this is one of the most important function. This function will not come in your 11th class, but it will definitely come in your 12th class, and apart from that it will come in your NDA exam and other competitive exams like IIT J. Okay, and the graph of this function is drawn like this. The value starts from the here, and it is 1, and it is minus 1, it is 0, and x dash y dash. Okay, so why I have made a circle around this dot? Okay, it means that the minus 1 is not included. Okay, and here 1 is not included. And what if the value of x is equal to 0? If the value of x is equal to 0, the function will give 0, and it need not to be drawn here. Okay, this is the graph of this function, and we can also write y is equal to, here it is y equals to minus 1 and y equals to 1, because the value of y here is 1 and y value is 1, minus 1 here. Sorry. Okay, now let's talk about the greatest integer function, but before that pause the video, note it down. Okay students, our last part is 7th part, and it is greatest integer function. Okay, so let's see what does this greatest integer function means. And this one is also the important. I am marking this hash. Okay, this type of function is defined on the real numbers. Function is defined on real number. You may be saying that each and every function was defined on real numbers, then what was the need to write function defined on real to real numbers? There is need to write real to real numbers, and if you will not write this real to real numbers, examiner will not give you marks. Okay, he may understand that the function which you have written may be defined on the rational numbers, irrational numbers, or anything he may understand. Okay, let's see what does this mean. In this function, fx equals to this bracket x, which means that x belongs to the real number, and we assume that the value of greatest integer function is less than or equal to x. This is the main point I'm writing here. Value of x is assumed to be less than or equal to x, is less than or equal to x. Assumed, I'm writing here assumed because it is assumed. We cannot say that it is the exact value. It is our imagination, or we have taken. Okay, the graph of this function is drawn like this. So what does this lines means? Let me draw the graph properly. X dash y dash. Okay, see here I have, let me write down the values also. 1 2 3 minus 1 minus 2 minus 1 minus 2 here, and minus 1 minus 2 here. It means that the value of, let's see here, let's take this here it means that the value greatest value is 2 and the value of x is decreasing continuously, and in this also the value of x is decreasing and the maximum value is 1, and same here. Okay, now let's talk about algebra of real functions. Students, note that signum function and greatest integer function are very important from the competitive exam point of view. Okay, you must remember these type of functions. I know some many teachers doesn't tell you this because there is no part, there doesn't comes a part in the exercise. Okay, what comes in your exercise is just the algebra of real functions, which I'm gonna tell you right away. But and let's do algebra of real functions, but before that pause the video to note it down. Okay, let's see what is algebra of real function. Okay students, this type of algebra you need to follow in these functions. Our very first part is addition. Okay, suppose you have given that f plus g defined from x to a real numbers by, okay, you are given that f plus g is defined on x to the real numbers, and since now that x is defined on real numbers and g is also defined on x to the real numbers, these are the two different functions, and these two defined different functions are defined on x to the r. Okay, okay, let's see what we'll have. F plus fg function to the x, we have f of x plus g of x. It means that the function is f plus g is defined on x, and when we define this function we have f x plus gx simply. Okay, suppose that you are given that 2 plus 3, what you will write? I think 5. Okay, this is what you actually need to do. Don't mess up with this. Okay, and if you mess up with this you will never get the functions. Okay, what you need to define, what you need to understand is the addition, subtraction and division, multiplication. These are the quite simple. Okay, this basic algebra you need to follow in these functions. Okay, let's talk about the subtraction of a real function. Of a real function, okay, same here. Function is defined f, the function is defined on x to the real numbers. I'm writing here because I didn't write here. And other function g is also defined on x to the r, and combinedly we can write it as f minus g is defined on x to the r, and when we need to define this we can write it as fx minus gx simply. Isn't this quite simple? It is quite simple, because if you understand it properly it will be quite simple, and if you don't understand it will be a mountain for you guys. Okay, you will never come to learn this, what is subtraction of real function, addition, etc. Okay, let's talk about the multiplication by a scalar. Okay, let's talk about multiplication by a scalar. Multiplication by a scalar means that a function is multiplied by a scalar simply. There is no long in this. Suppose that the function is fx and fx is equal to y, And the function, when it is said to you that multiplication by a scalar, you may write it as multiplication by a scalar, you can write it as af to the x, and the result will, which will you have a f x, where a is a scalar, okay, and x belongs to the real numbers, okay. So what was the meaning of this fx is equal to y? We have considered a function fx is equal to y, and we have multiplied a, a scalar a with this function fx, and the result which we will have is a multiplied by fx, okay. Now let's talk about multiplication of two real functions. Of two real functions, okay. So what does the multiplication of two real functions give us? The product of multiplication of two real functions defined on f x to the real numbers and g x to the real numbers is a function which is defined on f fg, sorry, this is these are the two functions, okay, real value functions preferably, such that these are defined on x to the real numbers, and when you need to multiply this by x, you have fx into gx, okay, simple. Now this was the fourth part. I by mistakenly write it third part, and last part is quotient of two real functions, but before that pause the video to note it down. Okay students, let's talk about quotient of two real functions. This is our last part, and this is fifth part, quotient of two real functions, of two real functions. Okay, the let f and g be the two real functions defined from f x to the r, where x is subset of r, and the quotient f by g is denoted by f by g is a function defined. Let me write it down, you may not get this, that we have considered two function f and g, and these are defined on x to the r, okay, and x is this, x is subset of r. It means that the x which we have taken here is a subset of the real numbers, okay. Okay, and f by g is denoted as f by g, it is denoted as like this, okay, and the function which is defined is written here like f by g x equals to fx, okay. This is how a function is defined. A quotient function is defined. F by g into x gives us fx by gx. I think I know some of you may be wondering that I could directly start the exercises, but when I directly start the exercises, you will not come across the deepness of these topics. Okay, that's why I'm telling you these topics. These are very important for the concept building and for the exam point of view as well. Now let's talk about the 16th example, and but before that pause the video to note it down. Okay students, let's take the 16th example. Okay, we have considered that f equals to fx is equal to x square and gx equals to, we have two distinct functions, gx equals to 2x plus 1, be two real value functions. We need to find out f plus g of x and f minus g of x and multiplication of these and division of these. Okay, there are four parts of the 16th example. We need to find out f plus g of x, f minus g of x, and f g of x, and f g of x. These are simply what we have read before and which comes in our algebra of real functions, which we have read right away. And let's talk about f of f plus g of x. Let's write down the solution here and let's begin. F plus g of x, x square plus 2x plus 1. This is what we have got from adding two functions f and g. I have directly written here x square plus 2x plus 1, and okay, this is f of f plus g of x, and f minus g of x is x square minus 2x plus 1. Now plus will not come because we have subtracted this whole function from this set. Okay, minus 1. Okay, let's talk about the multiplication of these two functions, which will give us x 2x cube plus x square. This is what we will get from multiplying these two functions, and when we need to divide these two functions, we will have x square plus 2x plus 1, where x is not equal to minus 1 by 2. Look here, why did I write down minus 1 by 2? X is not equal to minus 1 by 2. The reason here is that what if I put minus 1 by 2 here, I will have 0 here in the divisor. Okay, the divisor will be 0 because we cannot divide what we if we will divide x square by 0, the function will be not defined. Okay, that's why I have written here minus 1 by 2. And this was the 16th example of this exercise 2.3 intro. Okay, and each and every algebra I have applied here. Okay, I'm not doing 17th example because this 17th example is similar to the 16th example. You may try yourself, and if you have doubt, write in comment section. Okay, this was the exercise 2.3 intro of this chapter second, and thank you for watching this video. And if you like this video, please subscribe my channel and hit the like button. Thank you.